So today is a more open-ended lecture. Like the first two lectures of this review week were kind of structured. I had certain things that I wanted to cover, certain things I wanted to show you. This one's more open-ended. I have some stuff prepared. I have, like, just in case nobody has suggestions or ideas, I had a car example prepared where I was going to apply the state pattern to a car. I asked the previous lecture that I just came from, and they said, Jesse, that's dumb, we don't want to do that. So what they suggested was to go through how GUIs work, how in homework 2, like how all the handout code that I never explained works, everything in the view and controller package. And I went through that, and I think they like that more than the state pattern. But I'll give you the same opportunity. If there's something else you'd like to see, I'm pretty open-ended to what we cover on this lecture. But by default, I'm going to get rid of my car example and do what I just did in the previous lecture, what they demanded. Not demanded, but what they asked for. But I'll wait a minute or so in case y'all have something else you'd like to see. Otherwise, I'm going to show you how GUIs work at a rather rapid pace. No, we're well past it now, but can we see, but can we see a polymorphism example again? I'm frankly still trying to wrap my head around it. So I don't know if I'll go in the whole example, unless there is more support for that. Whatever there is for polymorphism? So who wants to see a polymorphism example? And who'd rather see GUIs, how GUIs work? Okay, quite a bit of GUIs. I think the GUIs still won there. So I'll quickly go over a polymorphism example. I mean, we've been doing polymorphism for 4 lectures. We haven't done GUIs at all, so I would vote for GUIs as well, for what it's worth. But I'll quickly do a polymorphism example. I have one sitting here. So like this would be, I don't know if I go all the way to polymorphism in this, but I'll use this to explain. So an example we had way back, I haven't used this one in a while, but a Pokemon class, which defines like what a Pokemon is. A Pokemon's going to have a name, a Pokemon's going to have a type, Pokemon's going to have HP, and the behavior of being able to take damage. And then whenever we want a certain type of Pokemon, for grass-type Pokemons, I'm going to extend Pokemon and then add whatever functionality I need for grass-type. For this, we're just going to override that type. We haven't seen this. I didn't show this in lecture. We won't throw it at you on the quiz. But we can override variables just like we can override methods. Typically, we'll just change the value instead of overriding it. But if you want vals, you can override those vals to be able to change it in your inheriting types. So we'll override that type to be grass for grass-type Pokemon. And then for Bulbasaur, Bulbasaur is a grass-type Pokemon. And then we put any Bulbasaur-specific things inside the Bulbasaur class. So we have inheritance where Bulbasaur extends grass-type extends Pokemon. And then we would have multiple grass types extending the grass-type class. We'd have multiple other types extending Pokemon. We'd have multiple Pokemon extending each of those types and build out this big inheritance type structure where we have hundreds of Pokemon classes, all of extending different types, and then those types all extending Pokemon. So they're all Pokemon, but they're all of different types and different species of those types. Where polymorphism comes in is when I actually develop my Pokemon game. I'm going to code everything to just work off the Pokemon type. I don't care if they're grass type, fire type, steel type. I don't care. I don't care if they're Bulbasaurs, Charizards or whatever, or Venusaurs. I'm stuck on my Gen 1 starters there for my examples that popped in my head. But I don't care what their actual Pokemon are. I just care that they extend the Pokemon class. So somewhere in my game, I'm going to have a list of size up to 6 that are my Pokemon that I have. And as long as they're all of type Pokemon, I don't have to code what their specific types or what their specific species are. I just care that they extend Pokemon at some point. I'm able to do that by using polymorphism because they're extending Pokemon. I can just treat them as Pokemon, and I don't have to know what type or subtype they are. Didn't you ask for the Pokemon example, and now you're not even paying attention? Christ. Right behind you. Didn't you ask for the inheritance, the polymorphism example? I thought you did. It was just that. Oh, I thought I saw your hand as well. I was ready to flip. Okay. Yeah, what's up?
So, like in the memory diagram, like let's say if Pokemon is grass type, it's extended. It extends.
Mm-hmm.
You have to draw a stat frame for Pokemon as well.
Yes. So I can't say new grass type. Well, I guess I could in this example, but this would be abstract as well. But I can say new Bulbasaur. When I say new Bulbasaur, the Bulbasaur constructor goes on the stack, then the grass type constructor goes on the stack, and then the Pokemon constructor goes on the stack. So all 3 constructors will go on the stack, and then any constructor parameters of all 3 classes will go on the heap as state variables. So this name, bless you, this name, oh, this gets wonky because there's an override there for the type. This name, the current HP, the type, this name, so we have 2 state variables called name, which is, I didn't prep this example for lecture, so we have that wonkiness going on. And then no constructor parameters here, so no extra ones. Like if this wasn't here? What do you mean, like here? Like no functionality? Like this?
Yeah.
So this would be an abstract method, and actually this is an abstract variable as well, something we haven't talked about, and something that won't be on quizzes. Then this is still going to go on the heap because it's overridden here and has its definition here. And the methods, we don't put in our memory diagrams at all. We'll put on stack frames when a method is called, but the methods themselves don't show up in our memory diagrams. So it wouldn't matter if this is abstract or not. With it being abstract, that means one of its subtypes has to override that method, and we're going to get an error here because we never implement that method.
Then grass type, like stat frame for grass type, it would be like Pokemon would store
Let's see.
grass type with the heat.
Yeah, so all 3 of the constructors are going to have this, which is a reference to the object being created. The grass type constructor will also have a variable called name, and the Pokemon constructor will also, the stack frame, will also have a variable called name, and both those names will end up being state variables. Good, cool. Any other questions about polymorphism before I shift gears? If we're storing a grass type in a Pokemon variable, does that open the header for Pokemon and a grass type on the stack? When we're storing grass type in Pokemon variable, does that open the header for Pokemon or grass type in the stack? If you're storing it in a variable, there's no stack frame. Like just for a variable assignment, there's no stack frame involved. But if you're calling a method that takes it as a parameter, that method would create the stack frame. And there'd be stack frames when you're calling the constructor, but just storing grass type in a Pokemon variable wouldn't do anything with a stack frame. It would just assign that reference to the new variable, if I'm reading this right. Specifically a declaration. So when I say new Bulbasaur, I get all 3 constructors on the stack. Do I have a test for this? No, I don't have any tests. I don't have any usage of this code. It's just a toy example. All right, thanks. Cool. All right, on to GUIs. So we have this GUI 2D. This was, bless you. This was one of the first programs you ran in this semester, and I wasn't going to explain it all, but since the previous lecture asked for it, we're going to do it. Oh, I changed the circle to red in the previous lecture, so. But it was green when you called this before. We had you run this in the second week of lecture, the very first lab. We had you run this to make sure that you had your versions of Java and Scala set up correctly. The reason for that was when we get to LO2, when we got to LO2 and you ran the self-checkout GUI for the very first time, that uses the same libraries as this does. So we know if you can run this program, you can run the self-checkout GUI, and that you wouldn't have IntelliJ issues then. So I like to get all the IntelliJ setup done right away, so mid-semester when homework 2 comes out, we don't have to go through IntelliJ setup and incompatible versions of things and silly stuff like that. We don't have to do that again, we get it all done right away. This GUI doesn't do too much. I'm not too big on like graphics and design and stuff like that. I'm more focused on functionality, so yeah, the GUI doesn't look great, but it's a proof of concept that we can do things with the code that you know how to use. So this GUI, we have a circle, which I call the player, which with WASD can move around, so we can react to keyboard inputs, and then when we click, we can spawn these spinning rectangles as a proof of concept that we can react to mouse inputs. So you can react to the player's mouse, react to the player's keyboard, and you can put graphics on the screen with animations. Once you have all those concepts, all that functionality, it's up to you to be the designer and the creative person to be able to build whatever the hell you want with this. We saw the jumper game. Again, the graphics were all just rectangles. But that's something that you could do with this functionality to be able to do that. You can also, instead of just doing shapes, you can add images to your GUIs and have actual sprites and things like that. You have the power to do that. But let's see how this was built, and then once we see how this is built, we'll go over to the homework code, and I'll explain how that homework code works. And hopefully we can get through everything. It will be a very fast pace. As told the previous lecture, that if I were to cover the content I'm about to cover in a way where I'm going to ask you to do it on a homework and ask you quiz questions about it, it'd be at least a week of content. So it's going to be very, very fast. But I'm not going to assess you on this content. It's just what was asked for. So let's go through it quickly. So very first thing with this GUI 2D, we're importing the ScalaFX and JavaFX libraries. We're using both. ScalaFX is really the library we're using, and ScalaFX is a wrapper library for the JavaFX library. So we're really using JavaFX, but ScalaFX is a go-between, so we can use Scala syntax to interact with our Java library. This is why we needed both your Scala and Java versions to be correct. We needed Scala 2.12 or 2.13 and Java, I think it's 13 plus, and then we had you install whatever the latest one is. I think we're up to 17, Java 17 at this point. But if you have too old of a version of Java, it's not compatible with this version of JavaFX that we're using. And luckily those were the defaults. Those are the current defaults with IntelliJ. So I think we had a pretty easy time this semester. And then there were other issues, but it wasn't too bad this semester. So we're importing these. If you're expanding on what's here, what I'm showing here, and you want to build your own GUIs with more functionality and things that I don't have any examples for, one, when you're importing things, always import the ScalaFX version of the class unless you're handling events. These events, for whatever reason, you have to use the JavaFX or you get bugs. There are ScalaFX versions of these, so I can include ScalaFX key and mouse events, but I get errors. Those errors took me like a day to figure out what the hell was going on there. It's because you need the Java version of those. So just a heads up on that. Don't waste a day like I did. Java, and then for everything else, the Scala versions. Like there are Java FX. Versions of everything else, but again, you'll get errors. And when you're looking up documentation, if you want to say, like I just mentioned images, if you want to figure out how to put an image on your GUI, I recommend finding the Java FX documentation and then taking that Java FX example in Java and then translating it into Scala. It'll be different syntax. You won't be able to cut and paste code like you may want to, but you'll be able to find all the important information, what the class names are, what the state variables are that you can access and modify, the methods that you can call, all the state and behavior and class names, all of that stuff you'll be able to find from the Java FX documentation. The Scala FX documentation is quite a bit lacking. There's just not a whole lot out there. But Java FX, there's tons of documentation. So it's a lot easier to find what you're looking for in the Scala FX version than just convert it over to Scala code. So enough of that, let's talk about what we're actually going to build. We're going to build an object of type GUI2D. I'm going to name it GUI2D. It's whatever you want to call it, whatever you name your object, and then extend JFX app, Java FX app. JFX app is going to have all the good stuff to be able to set up your GUI. Inside this, we're going to have all kinds of stuff, including a main method. So we're inheriting a main method from this other object, from this trait actually. From this trait, we're going to inherit the main method, and that's the method that's going to be called when we run our code. So we're not even controlling our own main method. That main method is going to set up all the GUI, all the good stuff that we want. And then our job in our code is just to tell it what we want to actually display. So let's do that. So when this is created, when this GUI2D object is created, which is as soon as our program runs, we're going to run all of the code outside of the methods, and I'm going to use that to be able to create quite a bit of state variables in this GUI2D object. I'm not going to go through all these. Some of these are just me naming constants. What's a trait? It's like an abstract class, except it can't have constructor parameters. So it's a little more limited than an abstract class. And we use them if we want to have multiple inheritance. If I want to extend, I don't know, button listener, there's a constructor. Well, you get the idea. But if I want to extend multiple things, I can only extend one thing, but I can mix in with the keyword with any number of traits that I want. So if I want to use multiple inheritance, extend multiple classes, I can do that with traits, but I can't do that with abstract classes. It would be the reason to use traits. So I'm going to skip some of this for now and skip right down to this. Like these, I'm creating variables, I'm running some code, I'm setting some things up. And then right here, I'm setting the value of an inherited state variable named stage. I inherited this from JFX app, and I'm going to set its value to something that I control, something that I want, instead of using the default value. For this, we're going to use some new syntax. We're going to use this initializer code. So when I create this primary stage, it doesn't take any constructor parameters, so I don't have to worry about the parameter list of the constructor. But then right after that, I'm going to put a code block. This code block, when you put it right after a constructor call, is going to be called after all of the usual constructor code. So the constructor is going to set some default values for all of its state variables and not let us control any of those state variables through constructor parameters. And then the library anticipates us using this initializer code to change the value, override the default value of any state variables that were set to the values that we want. This is just the way the library is set up. This is The alternative would be to have a constructor with like 20 parameters, and the developers of the library said, that's gross, we don't want to do that. We don't want you to have to specify 20 parameters to create instances of this. We can use default values, but what if you want to change just the 18th parameter? Now you can't use default values for the first 17. So instead we use initializer code and just override whatever we want. I say override, but not in the inheritance sense. I'm saying override, just changing the values of these variables. So I'm going to change title and scene are the two that I'm interested in right now. Title 2D graphics is, I did close it again, didn't I? It's going to be too small to see, but this is what shows up in the title bar of the window. It says 2D graphics. That's whatever I put right here. That's going to be the title of the window that's created for my GUI. GUI, I forgot this in the other lecture too until midway through, but GUI, for those of you who haven't heard that term before, GUI, pronounced GUI, stands for Graphical User Interface, which just is the window that we're seeing. Like when the program pops up, that's a GUI. We're looking at the IntelliJ GUI right now. So if you haven't heard that term, just to clarify what that is. I get that question a bit when I don't define it. And then I'm going to override the scene state variable to be a new scene, which is going to define everything that the user sees. I'm going to give it two constructor parameters, width and height, which I defined above. So I'm going to have 800 pixels wide and 600 pixels high for my window. And then I'm going to use initializer code in addition to that. Set the content. This is everything, the scene is also, but this is everything that the user is going to see. This .content, I'm going to give it a list because it's of type list. Observable list, sure. It's a list, so I'm going to give a list of all the things I want the user to see. I'm only going to use one element here, which is going to be which is going to contain all of my stuff, which is my circle and all my rectangles in this case. So I'm going to put that in something called scene graphics, which I created up here, which I'm going to go backwards now and fill in what we skipped. Scene graphics is going to be a group, which again is from the library. All these types are from the library so far. I'm going to create this group, which is going to be a collection of all of my shapes. I'm going to create a new circle to represent the player. I'm going to put that player at a random XY location on the window, and then specify the radius, how big this circle is going to be, and what color that circle is going to be. Then add that player circle to my scene. So when I add this scene to the list of my content, and that scene contains my red circle, then that red circle is going to be displayed to the user. All right, next we're going to add a couple event handlers. So there are many events that occur during the run of a GUI. The ones we're concerned about right here are events that are actions taken by the user. We want to react to our user. Writing software that reacts to the user is generally a good idea if you're writing software that somebody wants to use. So let's see how to do that. I'm going to add event handlers to the stage. We're still in the primary stage initialization code. I'm going to specify the type of event that I want to react to, and then how we're going to react to those events. So for this, I'm saying I'm going to react to the key event type, and specifically whenever a key is pressed. So you can have pressed, I'm not even going to remember them. Pressed, released, and I forget what the third one is. But one when the key goes down, one when the key comes up, and another one if the key is tapped. I forget what that third one is. You know what? Typed. Typed is like just a brief, somebody hit the key, didn't hold it down. If you hold it down, it's not necessarily a typed. But I'm worried about pressed. That's the one I want to use. Bless you. And then when the key is pressed by the user, I'm going to summon, I guess, key event handler, which is the first class that I've written. So we're going to go over here and take a look at that class. These two are a different GUI, but these three objects, these two classes in this object we're going to see. So key event handler of player is going to react to this key event. So this needs to be something of type event handler, which is going to take a type parameter similar to our arrays, lists, and maps. It's going to take a type parameter of the type of event that we're reacting to. In this case, a key event. Through polymorphism. So this has to be that type. My key event handler is going to extend that type, which is from the library. So we're going to extend that type and then add additional functionality to it. This type comes with one abstract method named handle, which takes as a parameter a type matching the event type of the type parameter. So this is how we're going to handle key event types. And since I'm creating my own class here, my own key event handler class, I can add a constructor with constructor parameters. I want a reference to the player inside this objects of this type, so I'm going to pass that as a constructor parameter. I'm going to override that inherited abstract method. Is it worth going in here? So this just has an abstract method called handle, which takes something of type T, which is the type parameter. This is Java code, so the syntax is a little different. But we have handle, which takes a key event in our case, because that's our type parameter. And then I'm going to get the code of that key, which is going to tell me which key was pressed. And I'm going to pass that to key pressed, which is another method I wrote here, which is going to check which key was pressed, W, A, S, or D, and then I'm going to move the player in the appropriate value based on which one of those buttons was pressed. By translating, I'm going to translate it 10 pixels in whatever direction the user pressed, depending on if it was W, A, S, or D. Then I'm going to use the wildcard here to say if any key other than W, A, S, D was pressed, don't do anything and print to the user that key is invalid. So WASD moves me around. Oh, I fat fingered it anyway. And then if I hit any other key, I'm just going to specify, oops, spoilers. I'm going to just show what was pressed. Part of my reason for doing that is, like if I code this with lowercase WASD in my code, I'm going to see that in my display. I'm going to see that it's going to say W was pressed. That's an incorrect thing. And I'll be like, oh, capital instead of lowercase. It just helps me debug. Plus, I can see the names, the codes for every key that I pressed. Comma, period, first letter's capital, then the rest are lowercase. I need those codes to be able to write my code appropriately. So we're reacting to those key presses. We also want to react to whenever the user clicks the mouse. I'm going to create my mouse event handler, which is going to extend event handler of mouse event. I'm going to handle mouse events by creating a rectangle. And rectangles behave a little bit differently than circles. We're going to specify a width and a height, and then also the translation of this rectangle. The translation is the location of the upper left corner of the rectangle and how far away from it is from the upper left corner of the GUI. This is something that takes a little bit of getting used to. In computer graphics, images, multimedia, movies, anything in computers related to visuals, the origin is the upper left corner. Up here, this is the origin of my screen. That's 0, 0. Same with my GUI. This is 0, 0. And then the x-axis, the positive x, goes to the right, and positive y goes down. The y-axis is flipped. This isn't what we would expect for a math class. We would expect the origin to be down here, so it takes some adjustment. But this is the way everything works in the world of computer graphics, except maybe there's one thing somewhere, some obscure location that I never heard about. Anything I've seen, this is the way it works. The origin is the upper left. This will be true in homework 3 as well. You're going to have a grid system. The origin, grid location 0, 0 is the upper left corner. So that will apply to something you're going to have to do pretty soon. Just the way that it is in computer science, don't ask me why. Actually, I kind of know why, but I don't want to go down that rabbit hole. And the translation is where the upper left corner of the rectangle is, but I want these rectangles to spawn at where the center of the rectangle is at the mouse location. So I'm going to translate by half the height and half the width. So I'm not, where you click isn't the upper left corner of the rectangle, it's actually the center of the rectangle. So a little bit of translation to keep in mind when dealing with rectangles defined like this. I'm going to access my GUI 2D object directly, and then add this rectangle to my scene, and then keep track of all the rectangles in my all rectangles list. And then finally, the last step, I want these rectangles to spin. I'm going to define a function. I don't want to talk too much about the structure of functions, but I'm going to create a function which takes a long, which is going to end up being a Unix timestamp, and whenever this is called, I'm going to rotate every rectangle by half a degree. I'm going to give this function to an action timer, and then tell the action timer to start. What this does, what the action timer does, is calls my function, it tries, I should say, to call my function 60 times per second. So with ScalaFX, JavaFX, by default, your GUIs are going to run at 60 FPS, and your action timer is going to maintain that 60 FPS. I say try because if I have code here that takes more than a 60th of a second to run, or I get stuck in an infinite loop, or I just do something that's too inefficient to be able to get my frame rate at 60 FPS, then I'm not going to hit 60 FPS. But it's going to attempt, as long as my code is efficient enough and my computer is able to run it fast enough, it's going to attempt to hit my 60 FPS. And then I get my spinning rectangles. I'm not actually doing anything with the time, but this is where, like in Jumper, in the Jumper GUI, this is where I would take that timestamp, I would remember the timestamp of my last update, and then figure out the elapsed time, tell the game to update based on that delta t, and then go to my physics engine and say, hey, update all the physics of the world based on this delta t, based on that timestamp that I was given by the GUI. So that's where I would use that timestamp. And of course, I had to translate that. It's going to be a Unix timestamp in, I believe, milliseconds, right? Or microseconds? Nanoseconds? Anyway, it's going to be a Unix timestamp. It's going to bug me. My brain can't work fast enough. Oh. Why do I have two of them? Oh, because of the apply. I'm going down a rabbit hole. Doesn't even say. Nanoseconds. It looked like nanoseconds, but I want to make sure. So I get the number of nanoseconds since midnight, January 1st, 1970. For what it's worth, that's how Unix timestamps work. And then I need to convert that to the number of seconds that elapsed since the last frame. And then that tells my physics engine how much to advance everything. Okay. Long is a 64-bit int. The nanoseconds, that number's large enough that it'll overflow an int. So we need to use longs there. Yeah, that's a value that would go on the stack directly. It extends any val. Long does. Okay. That was fast, but that was everything in the GUI 2D. Any questions about that quickly? Again, this is a week at least of content. We're going quick. But at the same time, you don't have to understand it at any real depth. So you can just understand it at a high level, and that's fine. It would be a week of content if I was asking you to code it from scratch. Okay, let's jump over to the project. And take a look at this GUI and see some of the differences between this one and the one we just talked about. Similar setup, similar structure, except the very first thing we're going to do in the self-checkout GUI is create an instance of your self-checkout class. We're going to create a self-checkout object and use that for all of our logic. And then call prepare store, something that we're not using in our unit tests, but when we run the GUI, first thing we're going to do is create a self-checkout and then call prepare store. So in prepare store, you're creating some items, you're adding modifiers to them, you're giving them barcodes. All that's going to happen in this call of prepare store right here, so then you can play with the GUI and actually scan those items. Then we're going to start creating elements. We have some different element types instead of just rectangles and a circle. We're going to use some different types. First, text field. This is going to be the area for your display string. A text field, and I'm going to use that initializer code to just make a few changes to it. I'm going to make it so you can't edit it. This is for display purposes only, so I'm going to shut off editing and then change the style to 20-point Arial for what it's worth. And then I'm going to have a receipt display for the receipt area. This is going to be a text area, but I have quite a bit of functionality I want to add to the receipt area, and I don't want to jam it all in initializer code. So this is a class that I wrote that's going to extend text area. I want all the state and behavior, all the functionality of a text area, but I want to add some functionality onto that. So I'm going to extend it and then add my own functionality. I'm adding a state variable here, changing some of the existing state variables. I don't want it to be edited. I want to control its width and height, its font. The console doesn't, on the newer Macs, doesn't show up right, but it's supposed to be a fixed width font, but I don't know. I never looked into that, why it's not displaying right on newer Macs. Or if it's working on Windows anymore even. But anyway, and then we have a few methods: add item, add totals, and format receipt. I'm not going to go through all this, but this is how things are formatted when it's displayed. The one thing I will point out is when things are displayed on the receipt, I'm using this little bit of logic here to be able to round the prices to 2 decimal places, which is what we'd expect to see on our receipts. So you might notice in your testing, when you print out the price of items, sometimes you'll see the truncation errors, you'll see the 00002 or whatever. You'll see those things in your testing, but you won't see them on the GUI. That's because I'm rounding here. We are still getting that price that you see in your tests, but I'm rounding it just for the purposes of displaying on the GUI to the end user. If the description is too long, I'm going to make sure that it's truncated so things don't go off the edges, things like that. Just displaying it in a nice, pleasant way. And then we're going to start adding our elements to the, we're going to create all our buttons. So we're going to create our buttons. I'm going to create these as self-checkout buttons, which is another class I wrote which extends button. And is going to let me have a little more control over my buttons without cluttering up my main GUI code. I want this code somewhere else. I'm going to specify how big the button should be, how big the text should be, what should happen when that button is pressed by an event handler of action event. When a button is pressed, we get an event of type action event. And what should be displayed on that button. Then I'll set the size of the button, the font, all that good stuff inside the button. This on action that I inherited is going to be the event handler of what should happen when this button is pressed. So I'm going to create the button, the 1 button. It should display 1. It's going to have a number action. This is something I'll circle back to when we get to the end of this file. A number action, which has a reference to your checkout model. This should be a button that takes up 1 row and 1 column, and then set its font size to that. font size value that I have. This is so I can easily change the font size of every button by storing this in a variable. And create all my buttons with different actions for each of them. Finally, we get to the primary stage. Title, like we saw, scene, like we saw, is going to be a list with just one element again, except this time it's going to be a grid pane instead of a group like we saw last time. It was a group. I forget what I called the variable, but whatever I called the group variable. Now it's going to be a grid pane. The horizontal and vertical gaps are going to be 0. I think it looks better when the buttons are all right on top of each other with no gaps between them, for what it's worth. And then I'm going to start adding my elements using this grid pane, which is going to be a grid system. Again, 0, 0 is going to be the upper left corner, and then add these things on the grid. So my scan field, which is where your display string is displayed, is going to be in the upper left corner, 0, 0, and it should take up 4 columns and 1 row. So when we run our GUI, we can see this grid and see that this display takes up 4 columns and 1 row. So that's how I'm controlling the layout of these buttons, the structure of this thing. Each button, I'm going to use the default column span and row span, how big the thing is, how much space it takes up, is defaulting to 1. All my buttons I want to be 1 by 1. So I'm just going to specify the locations. You can double check and make sure all my locations are right according to this grid. And finally, the receipt area is going to be on over past all the buttons. On the first row, it's going to take up 2 columns and 5 rows. So that's how I'm controlling how big the receipt area is as well, by using this grid layout structure. And then I'm going to have an event listener that listens for mouse clicked events. And every time the mouse is clicked, I'm going to call update display, which I control command click to it, but it's right below there, which is going to call your methods, items in cart, subtotal, tax, total, and display string, and display all this information on the GUI. This is where, bless you, this is where some of you will see the strange bug where every time you click on the GUI, even if you're clicking on the receipt area, so even if you're clicking over here, you'll see things changing on the GUI. It's because all 5 of these methods, your methods that are displaying information, returning the state of the self-checkout, are being called. And if any of those 5 methods modify any state in the heap, which they're not supposed to do, they're just supposed to return information. If they're changing anything in the heap, then you'll have that bug where clicking even on the receipt area will update things. And usually whenever I see this in office hours, I tell you to write a test. This one usually exposes the bug. Write a test where you call price twice in a row. And I argue that price called twice in a row, it should return the same thing both times. And almost every time when you have that bug, it's going to return different things because your price method is what's changing something on the heap. And it's not supposed to. It shouldn't modify anything. It should just say, this is the price. And that price shouldn't change every time you ask an item for its price. That's because all these methods are called every time you click on the GUI. So that's the view. So the way this is set up is using an MVC architecture, model view controller. So we're separating all of our code into 3 distinct parts. The model you're well familiar with, that's where all of your code goes. That's controlling how the thing actually works, how the self-checkout machine actually behaves, all of its logic, everything that it should do, all of its state changes and all that stuff. The view is concerned with only how it's displayed. The only thing we did here was say, how should everything be displayed to the user? Where should the buttons be? How are we going to format the receipt? How are we going to do all that stuff? That's the only thing we're concerned about there. And then the last piece, the controller, where we create all these actions that I said we'd return to. The last piece is the controller, which is concerned about user inputs. How do we respond to user inputs? So these listeners, these event listeners, or event handlers that I added to all my buttons, these are all defined in the actions file in the controller package. And this is one case where I put multiple classes in the same file because these classes are like one line of actual code. So I just jammed them all in one file. But like number action is going to extend event handler of action event. Action event is the event that's triggered when the button is pressed. I'm going to handle that event by going to the self-checkout model, going to your model, and calling number pressed with the number for that specific button. Clear press is clear action. This is going to call clear pressed when that clear button is pressed. Enter pressed when the enter button is pressed. Checkout pressed, etc. These are going to map directly to your buttons. The advantage of having it set up like this is that your model doesn't have to know or care that it's being used as part of a JavaFX, ScalaFX app at all. It's just concerned with being a model and controlling how a self-checkout machine behaves. That's it. So, for example, if we wanted to change this into a web app, we're going to write a new view using HTML and CSS. We're going to write a new controller which has some JavaScript which converts button presses into AJAX calls, probably, which is going to go to your server, which is going to control those, convert those AJAX calls into calls of your self-checkout model like this. And then your model code does not change at all. If we want to rewrite this as a web app, or if we want to install this in an actual physical self-checkout machine, or if we want to use unit testing like we have been, your model doesn't change at all. Your model doesn't care how it's being used or how it's being called. That's one of the big advantages of model view controller. How things are displayed to the user, how we handle user inputs, and then how all the good bits happen, how all the good stuff happens. And we did it. We got through even with the polymorphism example. Rapid fire, rapid pace. But any really quick questions? I planned on going through the state pattern today with a new state pattern example. I didn't do that, but I've said quite a few times, hopefully everybody agrees, that you should only use the state pattern when you think it's beneficial to your life, to your career, to solving whatever problem that you're facing, right? Do we all agree on that? You use the state pattern when you decide it's valuable as a developer. Everybody agree with that? Is that a cool statement? Right. All right, have a great weekend. I'll see everybody Monday for Halloween.